for you up here at the top of the page. So you don't have to write it down, which maybe I should have had you do just so you can remember it better. But this guy right here, your zeros or your solutions or your x values for a quadratic equation can be solved using the quadratic formula in any situation. You don't have to be able to factor it. You don't have to be able to complete the square. You can solve any quadratic equation using this. You just got to identify your A, B, and C values. And so to do that, you got to make sure before you start, you got to set it equal to 0. And then the only other thing I was going to say to you, you don't have to have your squared term be positive when you use the quadratic formula. That shouldn't matter. Oh my God. It doesn't have to have an A value that's positive. So that matters if you're factoring, but not if you're using the quadratic formula. So any of these questions, we're going to start out, set equal to 0, identify your A, B, and C values, and then we are literally just going to plug them in to that lovely mess that's this big fraction. It's opposite of B plus or minus square root, and that's B squared minus 4AC, the whole thing over 2A. A, B, and C will just be coefficients from the actual question, or the actual equation that you're looking at. All right, so I'm going to go through, we're just going to set this first lovely equation equal to 0. So to do that, probably the quickest thing would just be to subtract the 4 on that side there. So we've got 3x squared minus x minus 4 equals 0. And I'm going to try and leave it so you guys can see that quadratic formula on the screen here while I do this. But your A value is just whatever the number is in front of the squared term. So this is just going to be 3. Your B value is whatever's in front of the x. I just have a subtraction sign. So what would you put in for B? -1. Good. All right. And then your C value is your constant term or the plain number on the end, which is just the -4. All right. So I'm going to do opposite of B would actually be +1 then. And then we're going to do plus or minus. It's B squared. So I'm going to do -1. And if I'm typing this in the calculator, make sure you put the squared on the outside. That first term should always become positive because you're going to square something. Frankly, when I do it on the calculator, I don't even plug it in as a negative number. I just do it as +1. And then minus 4 is part of the formula. The A value is 3 and the C value is -4. Everybody over 2A, which is going to be 2 times 3. And forgive, let me back up here 1 second. The question says we're going to use the quadratic formula to solve. It says to give the exact and what we call the approximate solutions. So I'm going to talk to you about that here. In the first 2 questions we're going to do, we're just going to have exact solutions, and then the one of the ones at the bottom will have approximate solutions, so I can show you how to do that. Now, this is where I just grab my calculator. I'm not going to do the square root. I'm just going to type in what's under the square root and figure out what that is. I just kind of do it in 2 steps. So -1 squared, 4 times 3 times -4. And I'm just literally, I just used parenthesis keys just like I typed it, or just like I wrote it on the paper there. And I'm going to end up, I did not take the square root, I just typed in what was under the square root. So the square root's still going to be here, but we'll have 49 underneath. The bottom of that fraction is just 2 times 3, so that's 6. Now, for this particular question, what I have under the square root is a perfect square, right? So we're going to have nice answers to this question. So nice, what we call rational answers. So they can be written as a fraction. They might be a plain number. So plus or minus, oops, I just almost wrote 49 again. Square root of 49 is 7. The whole thing over 6. So then, to get my 2 answers, I'm going to do 1 plus 7 divided by 6, which would give me 8 over 6. And if it's something you can reduce, make sure you do that. Both 8 and 6 are divisible by 2. So reduced version of that would mean one of my zeros is 4 over 3. So like if we were putting this on a graph, it would cross the x-axis at 4/3. The other answer is going to be 1 minus 7 over 6. So make sure you simplify the top first and then divide. So this would be negative 6 over 6, which would actually mean my other answer would just be negative 1. Now, in terms of like in my directions where it said exact and approximate solutions, you really only are going to have an approximate solution if you have something under the square root that's not a perfect square. So I didn't have that here, so I didn't round anything. These are my exact answers. Okay, so let's try, and each one of these is just a little bit different thing that you could run into. So I do want to set these equal to 0 to start first. So if I was working on this x squared plus 6x equals negative 9, I would start out and I would just add 9 to both sides. All right, once you're there, and you don't have to write this out, but I'm going to write it out for these questions today so you guys can see. A value would just be 1. I just have a plain x squared. It exists, though, so it has a 1 in front of it. B would be 6, and C would be 9. And then I'm just using the formula right above the example here to plug this in. Opposite of B would end up being negative 6. Plus or minus, all under a square root, you got B squared, so 6 squared. Minus 4 is part of the formula, and then A is 1 and C is 9. Everybody over 2A, so 2 times 1 there. Sorry, I don't know why this keeps popping up. All right, now, again, you can do this by hand, or I just try to grab my calculator to save a little time, but I figure out whatever is under the square root. So 6 squared minus 4 times 1, I really don't need to do 4 times 1. It's just a good habit to make sure you're putting all the variables in, or all the A, B, and C values in. But that ends up being 36 minus 36 under the square root, which is actually 0. Okay, so I have square root of 0. Anybody know what the square root of 0 is? It's 0. All right, now I want you to think about this for a second. If I've got negative 6 plus or minus 0. If I do negative 6 plus 0, what do I get? If I do negative 6 minus 0, what do I get? It's the same. So actually, in this situation, if you get 0 under your square root, the top of the fraction is just going to be the opposite of B over whatever your 2A was. So this actually just has one answer. And in this case, this is just an exact, I'm not rounding anything. It was a nice number. It's just negative 3. And then I just want to do just real quick on this question, just so you can see visually. I'm just going to sketch a teeny tiny picture. If you just get one answer, I just got negative 3. What that means is if I were to graph the related quadratic, negative 3 would just be the x-coordinate of the vertex, and then the y-coordinate would be the 0. So that would be a situation. If you just get one answer, if you get square root and you have a 0 under the square root, it just means the one solution is going to be the vertex. So that's what's going on there. If we were to have graphed this last one, this quadratic would cross in 2 places. This would just touch in 1 place. So that's why I only have one answer there. Okay. Now, 2 at the bottom. Each one, like I said, is just a little bit different. So I'm going to add x squared to both sides to set this equal to 0. How many x squareds do I have if I do that? 3, right? All right, so I got 3x squareds plus 4x minus 2. None of those other terms change. All right, so my a value is 3, b is 4, and c is negative 2. From there, we're just plugging it into our lovely quadratic formula. Opposite of b would be negative 4 plus or minus square root 4 squared, so b squared minus, sorry to use all the 4s, 4 is part of the formula. A value is 3, C value is negative 2. Everybody over 2A, which would be 2 times 3 for this question. All right, now I'm going to grab my calculator and figure out whatever's under the square root. So we're doing 4 squared minus 4 times the 3 times negative 2. Make sure you use the negative key if you're going to type it in the calculator, and use the subtraction sign between the squared and the 4ac there. Now this ends up being 40. And I did not take a square root, so 40 would be under the square root there. everybody over 6. Okay, now, unfortunately, we have to break down 40 because it's not a perfect square. So we're going to see if we can write that in simplest radical form. Does anybody know biggest perfect square that would maybe go into 40? 4. It's just 4. 4 times 10. So square root of 4, we could bring out a 2. The 10 would be left under the square root. So then I'm just going to replace that real quick. This would be -4 plus or minus 2 roots of 10, everybody over 6. Okay, now here's the deal. This depends on the question whether you could do this or not, but do not touch the radical. If the 3 numbers, the 2 on the top around the plus and minus, and the number on the bottom, if all 3 of those are divisible by something, then you can reduce this, which is the case for this question. So all 3 of those are divisible by 2. If one of them is not, then just leave it alone, but all 3 of these are divisible by 2. So my answer here, this will be my exact answer. Just divide each of these by 2. This -4 would become -2. All right, now, you're not going to see a 1 written in here, but 2 divided by 2 is 1. What you would just see is that square root of 10. Don't divide that by 2. Don't touch the radical, just whatever's in front of it. And then 6 divided by 2 is 3. All right, now, this is 2 answers written because I have the plus or minus. That's what we would call an exact answer. On this question, you could write for me an approximate answer, which I'm just going to show you how to do real quick. We're just going to grab, for approximate, anytime you have something under a square root that's not a perfect square, it's like a nasty decimal because it'll be an irrational number. So when I say approximate, we're just going to round to the nearest 2 decimal places when we do this, the nearest 100. So what I'm going to do on my calculator, I'm actually going to take and do -2 plus, and then the square root of 10. Okay, now this is important. I'm going to divide that by 3, but you have to figure out what the top is first. So if you're typing this in the calculator, just do the top, like I did -2 plus square root of 10. Just hit equals or enter, and then divide it by 3. Otherwise, if you don't, your order of operations, the calculator will take the radical 10 divided by 3 first, and then it'll add that to -2. So just be real careful. So if I do -2 plus the square root of 10 over 3, that is approximately equal to that 0.387, so I'm going to say 0.39. My other answer, we're going to do -2 minus the square root of 10. Again, you got to figure out what the top of that fraction is first. Just go ahead, hit equals on your calculator, and then divide it by 3. So about -1.72. If we were looking at Desmos, for example, and seeing where this graph would cross, these are the 2 places it would cross the x-axis, is what the numbers are. The exact answer just means I didn't round anything. This is exactly the correct answer. Here I'm just rounding a little bit, so we call that an approximate solution. All right, and then we're going to do one more. And then I'm going to have you guys look at a word problem on the back. A little application here. Okay, so set equal to 0 first. On this last problem, to do that, easiest thing would just be to add 7. So we get 2x squared plus 6x plus 7, then we're set equal to 0. My a value is just whatever's in front of x squared, so 2. My b value is whatever's in front of x, which is 6. And then my c value is my constant term or my plain number, which is just 7. You do not have to write those out if you don't want to. I'm just trying to do it for today since we haven't done quadratic formula yet. All right, so let's see. Opposite of b, -6 plus or minus square root. B squared is 6 squared. 4 is part of the formula. Then times your a value, which is 2, times your c value, which is 7. Everybody over 2a, which would just become 2 times 2 on the bottom of that fraction. Okay, now I'm going to figure out what's under the square root. So 6 squared, 4 times 2 times 7. All right, now for this one, I got a -20 under my square root. So we're going to end up with an I in the answer because we have a negative under our square root. And can anybody think, if I'm going to break down that radical, biggest perfect square that would just divide into 20? It's 4. What I do, and you guys could do a factor tree with this also, but I used to use the biggest perfect square. I just attach the negative to that biggest perfect square I can think of that'll divide in. Then, when you take the square root, right, square root of 4 is 2, square root of negative 4, that's a perfect square in imaginary land. This would just come out as 2i. Now, it doesn't have a negative or anything, it's just 2i. And then this 5 would still be under the square root. So I'm just going to go back over and replace this here. So we'd have negative 6 plus or minus 2i radical 5, everybody over 4. All right, and I tried to do these just so you guys could see. Not every question is like this, but very similar to the last one I just did. Do not touch your radical. If all 3 of these numbers are divisible by the same thing, which they are, around the plus and minus and the bottom, all 3 of them. If they're all divisible by something, whether it has an I or not, you're allowed to reduce that. Those are all divisible by 2. Just don't touch the radical. This would become negative 3 plus or minus just 1i, so you would just see an I. The square root of 5 would stay the same. The bottom of that would be 2. You cannot do an approximate solution here because I is an imaginary number. So this would be an exact answer, and I'm just going to say you're not going to find an approximate with an I involved. So I'm not going to actually do negative 3 plus or minus I radical 5 because it doesn't exist. It's an imaginary answer. So don't do an approximate anything. We wouldn't see a place on the x-axis that this graph would cross if we were to graph that. Does anybody have a question? Okay. On to the back, we're just going to do a little tiny application, but I am just going to, just to save some time, just going to skip this. Just cross off that one at the very bottom. We're just going to do the one at the top. All right. Now, hopefully this formula looks kind of familiar to you guys from our last unit. And major difference here is we're going to have an initial height of the object, which I didn't really have that, or either I didn't have an initial height or I didn't have a velocity, where this is going to have both. So it says a rocket is launched from a 100-foot cliff. So not from the ground, from a 100-foot cliff. So in that lovely formula, wherever you start out, or your initial height is what they call it, that's going to be the C value or the constant term. So I'm not going to start from the ground here. We're up on a cliff and we're going to launch this rocket. So 100 feet in the air. And then the initial velocity is 144 feet per second. So the 144 is just going to go in place of the velocity. And I'm literally just going to replace this. The negative 16, remember that's the force of gravity in feet per second. So that would be consistent as long as your question is working in feet per second. So height of my rocket here, be negative 16t squared. And then plus 144t, and then plus 100. That would be a formula we could use for this question. Okay. Now, I'm just going to sketch a tiny picture of this situation just as a reference here. So this is a little different than some of the questions that we've been doing before where we maybe did not have an initial height. So I'm not launching this from the origin. I'm just going to kind of eyeball, I don't know, let's say this is 100. I'm just going to mark that kind of on my y-axis, which really the y-axis here represents the height of your rocket. And the x-axis is going to represent time here. So it's going to actually launch from somewhere up on this cliff. So we would launch the rocket in the air. This is going to create a parabola shape, but the force of gravity is going to eventually bring it back down to the ground. So maybe something like that. Okay, now I just want you guys to think about this for 1 second. So you can't really use symmetry here in terms of finding the vertex and things like that because I'm going to do this in a different color. No situation attached to this. If I just graph this quadratic, the other part of this would cross somewhere on that side of the y-axis, which would represent a negative time, which we can't have a negative time. I really don't want to go out of the first quadrant here, but I just want to show you this is not launching from the origin, so I'm not going to use any kind of symmetry in this question, and I'll re-emphasize that in a second with one of the questions here. But these two questions right here are going to be a little review. This says, at what time does the rocket reach its maximum height, and then what is the maximum height? Where on the graph would the rocket reach its maximum height? Like at what point? Not specifically, but the vertex. That's what I was looking for. Okay. So anytime you're asked for maximum or minimum, it's just asking you for the vertex. Now, in terms of how this equation is laid out, right, where we're used to seeing our x value is the time, and where we're used to seeing our y value is the height. So does anybody remember the little tiny formula for finding the vertex if you've got a quadratic in standard form? Remember? Perfect. Okay. This is just negative b over 2a. The actual height, what we'll do to get that is we're going to plug in whatever we get for negative b over 2a. So that's what we're going to do for this question. Now, my b value is 144, right? So opposite of b would be negative 144. Very important. I want to divide that by 2a. So 2 times my a value is 2 times negative 16. So don't forget this here. If you're going to do this on your calculator, totally fine, but you've got to figure out what the denominator is before you do the division. So if I just type in, I'm going to show you the correct answer first. So if I just do negative 144, bottom of that fraction would be negative 32, right? So this should be 4.5. This is the time in seconds. Don't write this, but if I had done negative 144 divide by 2 times negative 16, it gives me the totally wrong answer. That would be 1152 seconds. That would be way, way too long of a time period. But what it does on the calculator, it does negative 144, divides that by 2, and then multiplies that by negative 16. So it's very important on a question like this. Just put parentheses around the bottom of that fraction, or figure out what the bottom of that fraction is before you do the division, because that's just a little easy thing to fix. So 4.5 seconds. Now, once you've got that, we're just going to plug it in to get our height. So I'm just using the formula up above that negative 16. In place of the t, we're going to put the 4.5 seconds. Please, please, please don't forget to square when you plug it in on that first term. And I'm writing too big, so I'm running out of space. But that's the main thing I see people do. So I'm going to say negative 16, and then in place of t, we're going to put 4.5. Just don't forget to square that. And then plus 144 times 4.5, and then plus 100. Now, I got 424. That's going to be in feet. So, and you don't have to, but I'm going to just come back and kind of label my little picture here. So, this would be the point 4.5, and then 424 feet in the air, just for a little reference. Okay. Now, we're going to see that the next two questions really relate back to what we've been doing with solving quadratics here. So this says, at what time or times does the rocket reach a height of 343 feet? So, will I hit 343 feet, or how many times would I hit that? Like, if you're kind of looking at my picture as a little reference, would this rocket hit 343 feet? It has to, right? Because it's going to ultimately go up to 424. How many times should it hit 343 feet? Twice, all right? Somewhere, I'm just going to eyeball this. It's not to scale at all. Somewhere on the way up to this 424, we're going to hit 343. And then when gravity starts to pull it back down, you're going to also hit that height again somewhere on the way back down. So I should have two answers to this question. That's what I wanted to try and emphasize to you guys here. So all you have to do for this problem, we're just going to say we want to know when the height is 343 feet, about how many seconds is it going to be. And if it's saying to you round to the nearest hundredth or round to something, it's trying to say to you, use your calculator to do this. Now, all you have to do, we're grabbing the equation at the very top, and in place of the height, I'm going to replace it with 343 because that's what I want to see. So I'm just copying that equation up above. The only difference is I'm putting in 343 in place of the height. Once you're done, just move the 343 real quick to set it equal to 0. So I have to subtract that. So then I get the negative 16t squared plus 144t. And then we're going to do 100 minus 343, which should just give us negative 243. From there is where you want to identify your A, B, and C values. All right, so A should be negative 16, B will be 144, and C will be negative 243. So we're going to be working with a little bit bigger numbers here, but we're just going to use the calculator. So opposite of B would be negative 144, plus or minus square root 144 squared. 4 times your A value, that's negative 16. Times your C value, that's the negative 243. Everybody over 2A, which is going to be 2 times negative 16. Okay, let me grab my calculator here real quick. So we're going to square 144, B squared, minus 4A is negative 16, and C is negative 243. I'm just making sure to use the negative keys for the negative 16 and the negative 243. And it's kind of a big number, but it's not a big deal. I did not take the square root, so it's 5184 under the square root. The bottom of this should be negative 32. Okay, now, I am not asking you to break down that radical. We're just going to write our answers to the nearest hundredth. So we're just going to do the rest of this on the calculator. So, I should have 2 answers, so I'm going to have to do this twice. Do negative 144, and it doesn't matter which one you do first. I'm just going to do the plus first. Square root 5184. Hit equals, just hit equals, because I want to know what that number, and that's actually a nice number, it's negative 72. Then divide it by that negative 32 on the bottom. So if I add, I get 2.25 seconds. That's going to be where it'll hit on the way up. And then on the way down, that makes sense, because then 144, 72 is half of 144. So if this was 72, then when I add it to the negative 144, we're going to get negative 72. You're totally right. It ends up being a perfect square. That's not always the case, but that 5184 is a perfect square for this question. All right, now, to get my other answer, we're just going to do negative 144, do minus. And if you figured that out was 72, you can type it in like that. I'm just typing it in under my square root here real quick. And then I'm going to divide that. Make sure you hit equals, and then divide that by negative 32. The negatives should cancel out. So my other answer, on the way back down, it's going to hit that 343 feet at 6.75 seconds. Does anybody have any question? Okay. Now, I feel like all the time these questions will say something like, when will it come back down to the ground? What is your height if you're on the ground? 0. Okay. Let me just for a reference, I just want you to look at the picture just one more time. Okay. Now, I know we said, okay, right, in the middle, this was 4.5. You can't just multiply that by 2 like we did on some of the other questions that we've looked at and say, oh, it's going to be 9 seconds, because it's not quite going to be. You would have a 0 on this left side for that equation, but not for the situation, because we wouldn't have a negative time. But really, when I want it to find the value for coming back down to the ground, I should have 1 answer. We should not have 2. The other answer, if we do the plus and minus, the other answer will give us a negative. So you just want the positive answer here. Because you cannot have, bless you, cannot have a negative time. So we're just going to do 0. Negative 16t squared plus 144t plus 100. And you don't have to keep writing that formula out. I'm just showing you we're going to have the same A and B values. So A and B are both, A is negative 16, B is 144. The C value, though, is different. So this would be 100. We're just setting it equal to 0. Everything else would look the same. So we're going to have negative 144 plus or minus square root 144 squared minus 4 times negative 16 times 100. And I don't think, whatever's under this, I don't think is a perfect square like it was on the last question. Let me figure it out here real quick. So we got 144 squared minus 4 times negative 16 times 100. Okay, so huge number. Okay, now, you can find both answers and don't pick the negative one. Does anybody know, just to have you think about this for a second, should I do the negative 144 plus or the negative 144 minus if I want my positive answer? Does anybody know? You could do both and just not pick the negative, but what, if I was trying to save myself some time? Do what? Why minus? Exactly. If you just do the one that will give you the positive answer, if you do negative 144 minus the square root, this is that 27,136, that'll for sure give me a negative number on the top. I'm just going to hit equals. It must not be a perfect square. And I'm going to divide that by negative 32. So this is about 9.65 seconds. You really don't need to do the plus. If you did on accident, though, 144 plus that, what's going to happen when you take your square, oops, ooh, fail. Sorry. You're going to take your square root, that 27,136. That gives you a positive number, but then I'm dividing it by negative 32, and we can't have a negative time. So that's why I don't want to pick that answer. But if you want to save yourself a second, just try to think, okay, which one would give me a positive time? And that's usually the one where you're going to subtract. Is anybody having a question? I talked